We want one proof on there.
So what's the guys? I'm on the video.
All right, so number 4. This was from the homework from last night. Again, we're doing proofs. So on this one, we have 2 triangles. Again, lots of stuff is already marked. Lots of stuff is given to us. We already know what statement we're trying to prove. We have some things that are given to us. Anytime you do a proof, you should be able to fill in a few things. If you have the general outline like you do on all these problems, which you will have when it comes time to take the test and stuff as well, you should probably go ahead and fill a few things in that you have to know based on what's given and what they're asking you to prove. Now, I went around and there's a lot of people that didn't have parts of their homework done. Some people didn't have any of the homework done. It is not acceptable to say, I didn't know how to do any of this. You should be able to at least look at this paper, read that you have these given pieces of information, and then look down here and be like, hey, there's a blank that says given, there's another blank that says given, and this was one of the given pieces of information. So guess what? That's also given, right? So this was a given statement. The other 2 given statements weren't written down anywhere, but the reasons of given were here. So these 2 blanks had to be these other 2 things. Now, does it matter what order you put them in? No. You could have switched them around. That would have been fine. They're both being given to you, and the next step afterwards is the next step after both of these, so it doesn't matter which one you write in which blank. But this part, HI, is congruent to segment LK, and HJ segment is congruent to segment LJ. Now, we need to also mark the things that we know. I already told you that these right angles are congruent. That's a theorem. Remember, all right angles are congruent. That's a theorem. It doesn't really have a name. You just can make that statement because that was one of the theorems we did way back at the beginning of the year. So, we already have the right angles marked. We also should be able to mark that these 2 are congruent because that was a given. And we should be able to mark that these 2 are congruent because that was a given. Once you have those things marked on the triangle, we're able to say that the triangles are congruent. How are the triangles congruent? Well, if you look at the diagram, we have 2 sides and an angle. Can I use SSA? No. SSA makes a bad word, right? We have 2 sides and a non-include angle. So SSA doesn't work. What works here? HL. Because we have a right angle, and these 2 sides would be the hypotenuse and the leg of a right triangle. So this would be HL, hypotenuse leg. Again, if you want to get specific, you can say hypotenuse leg congruency criteria. If you just put HL, that's fine. Now, we have another blank at the end. Well, what do I know has to go in this last blank? This last blank here. So this last box. What goes in there? Angle H is congruent to angle L. It's what we're trying to prove. It has to be that last spot, right? So now, if we ever go past the idea of the triangles are congruent, what has to be the last statement? CPCTC. So even if you didn't know anything else, if you had something that you're proving other than the triangles being congruent, we could have went through and at the very beginning of the sheet, let's say I dropped all the way down to number 6. Hey, I'm proving something besides the triangles are congruent on number 6. So there's a statement about the triangles being congruent. Whatever I end up putting in this box could be CPCTC. Right? And I know what I'm trying to prove in that box because it's given to me. So I know that IJ is congruent to KJ. Again, I could do it with any one of these. I can go through and do my final proof statement, and if it's something following a triangle statement, I should be able to label that with CPCTC. So a lot of you guys telling me that you weren't able to do anything on this proof, that's not acceptable. You got to try it. All right. I don't believe that you said you actually looked at this for hours and were like, I don't know how to do anything on here. All right. So on some of these, again, like number 5, all right, we have 2 given statements. So what's the reason for those 2 given statements? Given, all right? You can fill that out. Let's pretend I don't know anything else, all right, besides my given statements. Let's see how much we can write. So I filled in 2 out of the 6 blanks so far, all right? What else should I be able to fill in right away? The last one, yeah, because it's what we're trying to prove. HIK is congruent to triangle KJH. So I already have half of my points, right? I have 3 out of 6 answered. Even if you don't know anything, you got 50% on that proof, right? So now, let's look at the actual figures. This one was a little bit challenging. We hadn't seen one like this yet. But I gave you guys a hint. Don't use vertical angles and outline the 2 triangles. So let's outline these 2 triangles and see what they look like. So HIK is that triangle there. And then KJH is this triangle here. They're 2 triangles that are actually doing what? They're intersecting. They're overlapping, right? So it sometimes helps to identify what triangles are you actually solving for first here. Because we want to make sure that we're only using parts that deal with those 2 triangles. Now, let's label what we already know. All right? It said that IK, so that's this entire line segment over here, is congruent to JH. It said that HI is congruent to KJ. So, what do you think?
So I think HK should be congruent to itself.
Yeah, good. So on here, the thing that we need next is HK. It's in both triangles. So that's one question that you can ask yourself. Do we have anything that's part of both triangles? Because there's a good chance that reflexive property is something that's going to come up in some of these proofs. 2 of the most used properties that we've had so far, reflexive property, and then also vertical angle theorem. Those 2 come up all the time. So if you get stuck on a proof, look to see if you have any part that you could call reflexive because it's in both figures, or look to see if you're dealing with vertical angles. They come up quite often. All right. So this was HK, you said? Is congruent to itself, HK. Oops, HK. And you said it was because of reflexive property. And again, if you want to go as far as saying reflexive property of congruency, you can include that as well. If you just write reflexive, I'm fine with that. Side, side, side. So we have all 3 pieces that we have are all segments. So these are all the sides of our triangles. So that is side, side, side. Okay, let's go back down there to 6. So I had started this off a little bit. Again, we have this part already filled in because that's what we're trying to prove, and it came after the fact that the triangles are congruent, so it has to be CPCTC. We also have a given listed at the top. All right. Well, how many givens did we actually have? 2. I don't see another one labeled as given. Is the other given already listed? Yes. So let's go ahead and label that one first. So LJ bisects angle IJK. So this was also a given. This given would then have to be what? 1's congruent to angle 3. Now, I already have 1, 2, 3, 4. 4 boxes filled in, and I only have 1, 2, 3, 4 left. Again, I have half the proof filled in. And I haven't even done anything with real work yet, right? All I've done is identified the end statement and what's being given. So, next thing, all right, we have to use this statement since we're using an arrow to connect it to it. So what do we know because we have a bisector? Eli?
I think this is angle 3 and angle 1.
Yeah, I don't know if I like that because now I think they're congruent. I don't have anything wrong with that part. It's the fact that is that the angle that was being bisected? What did you say? Yeah, so angle 2 and angle 4, these two are the ones that are congruent based on this statement. Angle 2 is congruent to angle 4 because, again, this is the angle that's being bisected by this line. So this is congruent to that one. Right? So that's the statement that has to follow. So again, you have hints, right? Definition of angle bisector. What do we know because of the definition of angle bisector? Well, since this was bisecting this angle, the two parts have to be equal. All right. Now, there's one other piece that we'd have to know before we can make a congruency statement. Again, if you're stuck at this point, what were the two things that I said to look for?
Vertical angles and reflexive.
All right, do we have vertical angles in this one?
No.
No. Do we have something that we could use for reflexive property? Yeah. All right. So reflexive property would say that that line there, LJ, is congruent to itself. LJ is congruent to LJ. JL would be fine. So if you wrote that backwards and said JL is congruent to JL, that's the same line. That's fine. All right. Yes. Yes, that would also be fine. Yeah. All right. So now we have that statement. All right, and we said that because of reflexive property of congruency. Now, we have three parts. Now, I didn't label all the parts, so you might want to go back and label the one that I hadn't done yet. So, angle 1 and angle 3 were congruent. That was given to us. So, over here, those two are also congruent. So, you said angle, side, angle, ASA. We have two angles and an included side. So, ASA congruency criteria. Questions so far? Again, I want you guys to start recognizing there are patterns here that we can use to help fill some of these things in that appear all the time. I was in another math teacher's room just this morning for a department meeting. I saw a poster they had in their room about logic and reasoning and diagnosing a problem. Yeah, that's all this is. You're trying to figure out how to get from point A to point B. Why? How? It doesn't matter if you're a mechanic. It doesn't matter if you're a doctor. There's a reason why there's something going on. Or you have to get to this point. How did we get there? What's causing it? Again, that's what this is teaching us. All right. So even if you're not going to use this type of proof in real life, you're still using the logic and reasoning behind it. It's important to understand the why. So you have to know the ideas here in order to be able to use them. Now, on number 7, we have two triangles that are back to back. And again, we have some given statements. Well, were both those statements listed? They were? No, there's one that was not listed. So we can go ahead and add that one on. We already had that second statement listed, but the first one was not. So for number 4, GJ is congruent to JI. Now, the other one, I just want to run through this real quick. The other given, it said we had two segments were perpendicular. Well, because they were perpendicular, the definition allows us to label them as right angles. And then since they were right angles, we know that they are also congruent to one another because all right angles are congruent. Now, you have to get to the idea of congruency before you can get to saying the triangles are congruent because you need 3 congruent pieces. Right? So on here, we got that piece. What else do we know? Line HJ is congruent to itself. So HJ, that segment, is congruent to segment HJ. Again, you could have also listed it as JH. Why again? reflexive property. Now, what are we actually trying to prove here?
That line GH is congruent to line IH.
So GH is congruent to IH has to be this last statement.
So
What are we missing here? Oh, okay. We could go there for a second. That was my question. I'll come back to what Jade said in a second. But Eli, you said this would have to happen because of CPCTC. What we're missing in the line before that would be the statement about the triangles being congruent. So, yeah. Now, is there more than one way to state it? Yeah, so there's more than one acceptable way to state this. So what order did you go in? GHJ, all right, so GHJ. Now, once you make that first statement, you have to make sure that the other triangle corresponds. IHJ. Oops, triangle. IHJ. All right. So now, why? Well, what parts do we have? We have two sides and an angle. Is the angle between them? Yeah, so this would be side, angle, side. There's a lot of students like to call it SAS. All right. All right. Any questions on that one? Nope. All right. Let's go on to number 8. So now, on number 8, again, we have ourselves two triangles. Again, they're back to back. Chances are, if we have two triangles back to back, what's one of the reasons that we're going to end up having to use? Reflexive property, right? So anytime you see a line being shared, if you get stuck, you're probably going to have to use reflexive property. Now, there are two givens. Now, doesn't matter which one you list first. Does it? Sometimes it doesn't, sometimes it does. In this case, does it?
Angle ABD and angle CBD are right angles.
Why do you say you have to list that one first?
Because then they have the right angles are congruent.
Okay, so they gave us something here in between, right? They told us all right angles are congruent. I couldn't make that statement unless I knew I was dealing with right angles. So the first statement is going to have to be something about right angles. So the first given is going to be angle ABD and angle CBD are right angles. Yeah, I know there's not a whole lot of room to write that there, so just try to make it fit.
So then ABD is congruent to CBD.
Yep, so the same two angles must be congruent to each other. ABD is congruent to angle CBD. What was the other given?
B is the midpoint of AC.
B is a midpoint of AC. Ooh, I just realized there's a typo. There should be a segment there. Go ahead and add that in. All right, now, because we have a midpoint, what must be true?
That line BD isn't bisected.
Okay, I do agree with that, but is that going to help us prove the triangles are congruent? So, if B is the midpoint of AC, what's the definition tell us then? B would have to be bisecting AC, so what's true about
AB is congruent to BC.
AB is congruent to BC. AB is congruent to BC, because that's our definition of a midpoint. A midpoint bisects a segment into two congruent pieces. All right. So now, on number 5, we already have two parts marked as congruent here. We need a third piece. What's the third piece going to be?
BD is congruent to itself.
BD is congruent to itself. BD congruent to BD. Again, reflexive property of congruency. And finally, we're not quite done yet. We got a proof statement, but again, that's our last blank, so that proof statement has to go now. So ABD is congruent to triangle CBD, side angle side. How much time we got left? 9 minutes. All right. I want to do a couple other examples. So that's it for the homework.